Can you explain how the new robot classifications that were introduced in that updated standard or series of might influence the way that engineers categorize and design systems for safety compliance?
Yeah, and actually, this was this was an interesting experience, and we actually started working on this before COVID. So, um, we thought, again, based on the advent of power and force limited robots into this space, and uh, okay, I'm also going to take one more step back. I'm going to say, um, a lot of times in industry, I hear people talk about collaborative robots and industrial robots as if they're collaborative robot is an alternative to an industrial robot, but actually, according to the standards that we have, that and our standards enabled the creation of the whole category of collaborative robotics, and actually, a collaborative robot or power and force limited robot is a type of industrial robot, not an alternative to an industrial robot. So just going to leave that there. But basically, because of the power and force limited robots, which were just starting to come on the scene when the last edition was published in 2011, that those robots tend to be much smaller and less powerful than the previous industrial robots of yore. People were saying something like, well, this robot it can only pick up 10 kilograms or 5 kilograms versus this other robot that can pick up an entire car and wave it around. Surely we can say that they have different safety requirements. I mean, that made sense when we thought about it. And so our committee, working group 3, took a look at it. And we honestly started out thinking we would get a lot farther with classifications based on size and power because, I mean, when it comes to physics, weight wins, right? So actually, though, when we had a sub team studying it and coming back with a recommendation to the rest of the group, what we finally determined was it's actually a lot more complex than that. And so, weight wins, yes, but also there's trajectory as well. So, a small, relatively lightweight object, if it's moving fast enough, it can harm you. A large, powerful machine, if it's moving slowly enough that you can escape it, won't harm you or is less likely to harm you. And so it also involves, the speed as well as the shape of the object. Is it sharp or rounded? And what's the workpiece that it's holding? Is it hot or toxic or what have you? And so it just wasn't enough to say that the risk profile of a robot arm per se um, was, we just couldn't say with hard and fast confidence that, the risk profile of this quote unquote smaller robot was less than this quote unquote larger robot because of all those other factors. And so, yes, in the end, we ended up with class 1 and class 2, and that impacts certain safety functions, with a class 1 being a much smaller, less powerful machine. Um, and the thing that impacts those safety functions is whether they're required or optional based on whether it's a class 1 or class 2 robot. But in reality, most industrial robots and industrial robot applications are going to fall into class 2, which is the larger, more powerful class. And so it's probably not going to make a huge amount of practical difference for most projects involving robots, but there are some, that are using a very small robot, that it could make a difference.
What are the key takeaways regarding the new testing methodologies in 10.2.18, and how can engineers incorporate them into their designs and quality control processes?
hmm So, okay, some of the new testing methodologies have actually been available in another means for the last several years. So, for example, in the 10.2.18 Part 2, the 2025 edition, there is an annex, I want to say it's Annex N, on testing methods for power and force limiting applications. And that's basically how to test whether your power and force limited robot is actually working within those limits. That content actually first appeared as a US technical report, or TR 806, that I think we published in 2018. And we basically incorporated it as this annex in the 10.2.18. So now, again, it's another one of those examples where you used to have to buy a separate standard or a separate document, and now it's part of the main standard. And it's certainly possible that that's newly visible to people who weren't aware of the TR. So, definitely it's in there. The other thing is the testing of whether or not a given machine falls into class one or class two is obviously new because class one and class two as a concept is new. The main thing is the convenience of having it all as part of the main standard versus having to be aware that there's another document out there and going and getting it. When you get the standard, you have a lot of these things now built in that you used to have to go out and get separately. So I think that's one of the main benefits of the way we've done this update. For example, if you wanted to know the Power and Force Limited, how to test that, and you wanted to just read Annex N of Part 2, so you could learn how to test for that. I mean, that's good. I mean, don't get me wrong, I'm not gonna discourage anyone from doing that. But honestly, it's really important. It's very tempting to just kind of try to cherry pick the particular topic that you're interested in, but it's really, really important to read the whole standard and get an idea of the context in which those testing methods were developed. And it's just because all the parts of this, but both part one and part two, and all of the clauses within them, they point to each other and refer to each other, and they work together. And I really can't stress enough that it's very important to if you want to say that your machine complies with, for example, 10 to 18, it has to comply with the whole thing. And you can't say, oh, well, it complies with Annex N, and that's, it has to comply with the whole thing.
How can compliance with these updated standards create competitive advantages for companies in the robotics market? And what opportunities do you see arising from prioritizing the safety and the cybersecurity, say?
I have 100% rock solid belief in the value of keeping people safe around robots. I truly and honestly believe it is a ticket of entry for the success of our industry. And, failure to achieve it will not be good for our industry. So, I'm definitely a true believer in the value of this whole thing. I'm also going to admit that designing in the safety of the robot cell involves, at the very least, you have to invest in the safety fences and the interlocking and the controller that can handle the interlocking. You might end up getting a safety sensor that, these laser sensors, they can be expensive. Now, I mean, all the parts of the robot system taken together, someone could say, well, all of this safety equipment is adding to the cost of the robot cell. I can see how that could be said, but I also firmly believe that if your company is investing in an industrial robot system, you have a responsibility to your workers to invest in the safety of those workers. And safety shouldn't be considered optional. So it shouldn't be considered an optional add-on. It should be something that's baked into the design of your robot system right from the start. And in order to achieve that as an industry, it's so important for robot users, the user companies, to work closely and collaborate well with their integrators. And it's really important that users understand what's in the standards enough so that you know what to ask for from your integrator. It's really important that the users realize that they have to bake that into their statement of work that the integrator is going to fulfill. And so, I personally firmly believe that if you're going to invest in automation, you need to do it right. And doing it right includes keeping your people safe around it. So, and now having said that, I would say that, it the discipline of the marketplace actually can cause this to happen. Because if we've been talking about collaborative robot applications and the explosive growth of collaborative capable robots and robot applications. That's a case where that machines, main claim to fame is that humans can approach it and still be safe. And not only has it been growing explosively in terms of market share, but also in many cases, that type of machine has been able to command a price premium. So that's an example of where a machine that has, thoughtfully attempted to design in safety or um, design in features that cause it to um, be safe, collaboration capable. Um, those machines are are both growing exponentially in terms of numbers of sales and also are commanding a market premium in terms of their price. And so, that's an example right there where companies that have really tried to make that their selling point have been able to do so.
So,
Hmm.
have you seen yet what challenges maybe the engineers are facing in adapting to the new requirements of 10 to 18? And how do you think that they can, you know,
Yeah.
overcome any challenges?
Yeah, so number one, it I we all those of us who have been involved in this, we all recognize that it is a very large update. It's a very big change from 14 years ago. A lot has changed since 14 years ago. And probably the number one challenge is going to be simply to understand what has changed. And so really your first step right now is to, get a copy of it and start reading it and read it while taking notes and read it, you know, with take notes and see if some of your questions are answered in a later clause or a later section, and then go back and read it again. And then if you still have questions, you can come to Automate and talk to some of the people who helped write it because a lot of our committee members will be at Automate. They'll be presenting as part of the Automate conference. They'll be on the show floor in the booths of their employer companies, and you can literally just walk right up to them and ask, what your question is that came from having read the standard. But really, you got to start by reading it. If you are already familiar with the 2011, that's all the better. You can read the 2025 with an eye towards, oh, that's different compared to what you were familiar with in the 2011. If you actually are new to automation and you aren't super familiar with the 2011, just read it from the start. The other thing is that the working group 3 of ISO TC 299 that prepared the update of 10 to 18 is also working on a technical report. And this technical report will help explain what's different between 2011 and 2025. And so, what's different and what this means for you as an integrator, probably. And that technical report, they are working on that sort of at a feverish pace, trying to get that out into people's hands. The industry, the robotics industry, I've been working in this field now for 9.5 years. I came into it really having to learn much of it new, and it has just been a tremendous honor to be able to work with the types of people who populate our committees. They are, not only are they technical experts, but they also, care deeply about keeping people safe, and they care deeply about sharing their knowledge with the rest of our industries so that other people can be kept safe. Um, they're just really an outstanding group of people, and it's really been an honor for me to get to know them. So I want to thank our committee members tremendously.
Absolutely. Thank them very much. And thank you so much for being here, Carol. We really appreciate it. I look forward to seeing you in May in Detroit. And thank all of you for joining us today. Until next time, this is Sharon Spielman with Machine Design. Stay curious.